welcome back. Now let's talk about third angle orthographic projection. And in third angle orthographic projection, the basic about this is that the plan is directly above the front and the end is horizontally in line with the front. So basically, in terms of orthographic projection, we are mostly dealing with the relationship between the plan and the end in relation to the front elevation. So the lines used in orthographic projections that are projected from the plane to the surface are called the projectors or projection lines. Yeah. And then just a note to the student is that third angle orthographic projection, what you see on the left, you draw on the left, and what you see on the right, you draw on the right. I'll just briefly explain this in the next slide. And let's assume we have this model here. So for third angle orthographic projection, assuming this is our eye here, for third angle orthographic projection, the plane, this is our plane, this is our plane. So the plane is placed between the viewer, this eye, and the object. So as you can see, the viewer and the object, the plane is in between, and our plane is assumed to be transparent. That is, if you were to shine a light here, there will be no shadow formed at the back of this object. That is our 3D model. Our 3D model. So this is the orientation or the layout for third angle orthographic projection. This is a meter line. You can either use this format or you can use the arc method. Both are okay. So as you can see, the plan is directly above the front and the end is just horizontally opposite the front. As you can see, the relationship between the plan and front is what is used to describe and differentiate between third angle and first angle orthographic projections. So just a note to the learner is that for the sake of when doing your drawings, it is advisable that you do not draw both the end. As you can see, this will be our end elevations, but you are not supposed to draw both of them. You are only required to draw one, depending on the rule that you have used here. On the rule we have used up here, where the object drawn on the left is drawn on the left. So if you are to for example, in our example here, you can see that the viewer is on the left side. Assuming that this is our front, this shape is our front, then this is our end, and if this is our end, then the end elevation will be on the left of the front. So coming back to our example here, so the plan will be up there, and then the front will be here, and the end will be to the left of this. This is the required, so we will not be needing this one for the sake of the example that I have just demonstrated up there. But if the viewer were to be on the right side of the object, then of the supposed front, then the layout of the drawing will appear like this. That's the plan at the top, the front here, and then the end will be here. Sorry for using this, I was not supposed to draw this. You can just ignore it. So let's try the first example, and this will be our front, this will be our plan, what you see from the top, and this will be our end. So as you can see, if you are at the top, you will see these pink shapes and they will be represented here. This is our plan. Then this is our front, as you can see here. This is our front F, and the end elevation, as you can see, the viewer, when viewing the end elevation, is assumed to be on the left of the screen, of your screen. So the end elevation is on the left of the front elevation. Let's try another example too, and this is our model. From the top, the viewer will see the red faces, this red face and this, and you will also be able to see part of this blue face that is sloped, this part of the red face that is sloped, and that will be this is now the plan. This is the plan, and the front, this will be the front, this will be the front, all these that are marked green, as you can see, and these blue faces will make our end elevation. So as you can see here, end elevation, and as you can see, the blue face, which is the end elevation, is on the left of the screen, so it will be on the left side of the front elevation as shown in our example here. So that's just the basic principle. We can now go to how to draw circular and cylindrical features in orthographic projection. And for the case of circular and cylindrical features, we will introduce two special features which are the center marks and the center line. So you will need those features. Let's just discuss them on the next slide. So the blue line, as you will see, this blue line here, these blue lines, this and this, these are our center lines, and they, as you can see, they are placed on rectangular features. Rectangular features representing circular features, while the blue plus, this one, as you can see, it seems like a plus sign. This is our center mark and is placed on all circular features. That is at the circle directly. You place it on the circle, on the face of the circle directly. So I hope that makes it more clear. And we have an example that has a circular feature. So for this example, you will see that for the plan, you will see all the green faces, this green, and there's green in here. That is for the floor of this hall. And as you can see, this is the plan. Then for the front, our front is assumed to be on this side. Then we will see the red features. So this and part of this will be the front, while the end elevation, which is, as you can see, is assumed to be on the left of the viewer. Here is on the left of the viewer. Assuming this is my eye to represent the observer, you will see that the yellow face will be the yellow and this red face will be shown here, and this is how they will be represented on the end elevation. As you can see, the end elevation is still on the left side of the front, just as we have discussed on the rule of orthographic projection. Just remember that what you see on the left, you draw on the left, and what you draw on the right, you draw on the right. Just another note that, as you have noticed, or in this example, all the end elevations are drawn on the left of the right, because the end elevation is assumed to be on the left side of the screen as we have demonstrated. So the selection criteria for, sometimes you might not, the front elevation might not be specified. So what are you supposed to do in such a situation? What you are basically supposed to do is just look for the longest side or the side with most features, and I think that should be a good criteria to give you the front elevation, and the other side that remains is automatically the end elevation. So thank you. We'll just continue with first angle orthographic projection in the next section.